So welcome everybody. So today I'm going to start a new course today. Now I'm going to teach how to create gears, different type of gears in Solidworks. So as part of this course today we are going to learn how to create spur gears and helical gears. So as you know, Solidworks has already gear material library. So in gear material library you can see if we go to different standards, there are different materials. You need to go to design library in SolidWorks toolbox, and there you have different standards. First one is ANSI inch, then ANSI metric. ANSI is nothing but American Society of Engineers, and it is in form of inches and in the form of metrics. Then Australian standards, British standards, Canadian, DIN, Chinese, Indian standards, international standards, Japanese, Korean, and different standards. And also you have parts from companies, also SKF, different companies. So these standards have different proper materials. So these are all standard parts. So no need to worry about the dimensions and all. But today in this course we are going to learn how to make a gear of our own without any standards, and also we will see how to apply standard gears also. Those two things we'll see today in this course. Now I'm just starting to show the standards in the design library. So first from starting I'll show. So you need to go to the design library here on the right side. Just click on that, and different standards you can choose. You need to select power transmission. The problem is that not every standards in this toolbox has power transmission. So suppose if I go to ANSI, suppose I go to Australian standards, there is no power transmission. So I'm going to ANSI metric, there the power standards there. So gears. Now I'm going to select spur gear. So in this for this course we're going to learn about spur gear and helical gears, but there are many other gears such as internal spur gear, rack spur gears, that is nothing but rack and pinion, and you have bevel gears, straight bevel gear, pinion, and meter gear. Different kinds of gears are there. Different standards have different gears, so you can select whatever you want. But for this course, purpose of this course, we'll use only most to use things which are spur gears and helical gears. First we start with spur gears. So spur gear is nothing but a straight gear. You can say it's a basic form of a gear. It is used to transmit loads from one part of the shaft to the another part of the shaft. So spur gear, we are going to select, drag it and place in the window. Last you to make a derived part. So it is nothing but it's asking whether to make a part or whether to just read only. So if you click yes, it will just form like a surface. You cannot edit it, you cannot see how the gear is made. Just you can locate that and just keep it. Just for it is used, can be used for supporting purpose. So you cannot edit information. Even if you try to edit, no information will come. Suppose I want to create a spur gear of module 3 and number of teeth is 50. So you cannot do those kind of things. Suppose if you want to do those kind of things, first what you need to do is you need to take a lengthy step. So you need to create a new material and go to assembly. The thing is that you need to set the module and teeth which is not available in parts. You can just create, drag and select the part, but you cannot change the configuration of that. But if you go to assembly you can do that. So I'm going to assembly, I'm going to select the same spur gear. Now you can see that configurations will be applied. Configuration is nothing but the same part, different variations will be provided. So as you can see, configured component has come. It's a toolbar. It will automatically apply whenever you select a gear or any other material. So I'm selecting, now I want to select 3 module as I've said. So different modules are there here. You can select whatever module you want, that is your choice. I'm going to select 3, and I want to select number of tooths, that is 50. Whatever tooth also you can give. not a problem. So I'm going to select 50. Then pressure angle is 20 or 14.5. There are two profile pressure angles, but actually in there are three. In 20 only there's up two subcategories, but they are not included that in here. So for now we'll take 420. And phase width. Phase width is nothing but the length of the thickness. You can say the thickness of this per gear. So I'm take 50. Then hub style. I don't want anything. Then you can keep none. If you want on one side, that, or if you want both sides, you can keep both sides, whatever you want. Then hub diameter, 50 diameter, whatever hub diameter you want. And then the overall length, how much total length of the gear, 100. It's you wish, you can change anything. Then nominal shaft diameter, suppose I want 16. If you want any hole, you can keep inside. Then if you want any keyway is nothing but for keyways, rectangular keyways will be there. You can create all those keyways. So I want a square keyway on one side. If you want on both sides, you can do that also, not a problem. But for this tutorial, we are not using that. So I am almost created. So you can see here, you can go to the material configuration name. It will give the total information, whatever you have selected, and click OK. Now what you need to do is just keep it open, or you can close also, not a problem. Just go to the previous part. Now you can see that it has been updated. So if you want to check whether the information is updated or not, you can do one thing. Just I want to close. Actually, suppose you want to know how, you want to find out how this gear was made, or you want to edit this gear. So what you need to do is just go here, select the same thing, select the spur gear, and now but you need to click no. If you click yes, you cannot edit that material. Just you can use that material as side material. Now click no. Now see the thing, gear has appeared. Okay, so just to confirm that I've selected module 3 and 50 thickness teeth, sorry. So 3 module 50 t. So it is a confirmation that I have changed it. Suppose you don't want to change 50 teeth from 100, then this go to the assembly again, just delete this one. Okay, then click on material library, select that spaghetti again, just go to 100 and click OK. So as you can see, 100 has been applied here, teeth, number of teeth. Now just go again to that spaghetti. So you can see that it is only read-only format. So you can see 100 has been applied. So suppose I want to change it from module from 3 to 1 or 2, can do those also. Just you need to go to assembly. So what happens is the SolidWorks gives the latest dimensions here given. Suppose I give 1 will be applied. Okay, so 1 is applied. So different things you can select, automatically it will be updated. So it is showing in read-only format. You can see here clearly, means it says that read-only format means only you can read the material, means model, sorry, how to create that model. You cannot change. If you want to change, the SolidWorks software will show an error. So that the material history may be affected. So I advise not to edit this material. You can see how this material is made and create our own material. That's what we are going to learn how to create in this course. Okay, so you can know how to do this material also. This I am going to equations. This is a very important feature. No other software such as Creo or CATIA doesn't have this thing. So if you don't know anything about gear topic, we can see just from here and learn how to create a material, which I'll show later in the course. So you can see all the information has been given how to create. So creating material has just three basic topics. So first one is how to, just I'll go back in history. So how to, I will say how to create a material. First, whatever they have done is they have created a sketch, basic rectangle. For the moment, I'll switch off the dimensions so that you can clearly visible see. So I'm going to the rectangle. So they have created a rectangle, simple rectangle you can also create, and they have given some dimensions. Those dimensions are governed by equations. Okay, so 50 and 102. What are these things we'll see later, but I will show how to create those cases. So you can see here there is error has come up, no problem. Then click go to tooth cut. So they have created a teeth profile. This is a very important part of that gear. So teeth profile is very important. This gives the gear its gear teeth. So you can see here how the gear teeth has been formed. We'll discuss this one topic in very detail in later. Now just click OK, and they've created an extrude cut. So basically first they have used revolve, created a rectangle and revolved it, so make a shaft. Then they have given a teeth profile and use extrude cut to create. Okay, then I am going forward. So there are some breaks, root fillets, those are suppressed actually. Okay, if you want up you can unsuppress, but it will change the gear profile, so better it will let it be how it is. Now see here they have given circular pattern. So they have given 360 divided by number of gear teeth, or you can do in your own way. Just